Graph the linear inequality in two variables. Here's my linear inequality, 2x minus 3y greater than 9. I want to take this and I'm going to graph the solution on the Cartesian coordinate system. The first thing you want to do is graph the line as if it was an equal sign. And the way I'm going to do it is I'm going to put it in slope-intercept form and graph it that way. So what I'm going to do first here is I'm going to solve for y. So to solve for y, I need to get rid of this 2x first. I'm going to subtract 2x on both sides. It's going to cancel on the left. So on the left, I'm just left with a negative 3y. On the right-hand side, I want to put it in that mx plus b form. So I'm going to put this negative 2x in front of the 9. So it's going to be negative 2x plus 9. Like that. Now I'm going to get rid of this multiply by negative 3 on the y here. I'm going to divide both sides by negative 3. Now when you divide both sides by a negative number, it's going to reverse this inequality around. So I'm going to divide both sides by negative 3. I'll split it up on the right, and that's going to reverse the sign to a less than. All right, so on the left, I'm just left with a y. On the right-hand side, negative divided by a negative number is positive. I'm going to write this as 2/3 times x. I'm going to write x off to the side a little bit. And then I have 9 divided by negative 3, which is negative 3. So I can write this as a minus 3. All right, the reason I solved for y is that now I can graph this. This is the y-intercept. It's going to cross the y-axis at negative 3. So I'm going to put a point at negative 3 on the y-axis. And then I can use the slope to find another point. I can do rise over run. So starting from the y-intercept, I'm going to do a rise of 2 and a run of 3. So I'm going to rise 2 units and then run over 3 units. And it's going to create another point about right there. So I went up 2 to the right 3 using the slope. And that's all you need. You need 2 points to draw a line. I can draw my line now. But you have to be careful. If it's a strictly less than or strictly greater than, you need to make it a dashed line, which indicates that points on the line don't actually solve the inequality. There's no equal sign with it. But if there is an equal sign with it, if it's less than or equal to or greater than or equal to, you're going to make it a solid line. But in this case, it's strictly less than, so I'm going to make a dashed line. Use a ruler here and make a dashed line here. All right, now the solution is going to be either all the points above the line or all the points below the line. And what we're going to do is we're going to shade the solution. Now, if it's solved for y, if it's in mx plus b form, all you have to do is look at the sign. If it's a less than, you shade below. If it's a greater than, you shade above. Since we have a less than sign, I'm going to shade below. So you're going to shade everything below the line. That means everything in this area is a solution to this inequality. Another way to do it is just pick a test point on one side. If it's true, then that's the true side, shade that side. If it's false, then you shade the other side. But since I graphed it by putting it in mx plus b form, I can simply just look at the sign. If it's less than, you shade below. If it's greater than, you shade above. Ours was less than, so I shaded below. There you go.